In this video, we will discuss difference between traditional and concurrent collection. Most of the classes in the traditional collection like ArrayList, linked list, hashset, linked hashset, tree map, hash map are non-synchronized and therefore they are not thread safe. All the classes present in concurrent collection are synchronized in nature and are thread safe. Traditional classes have some classes like vector, hash table, and stack which are synchronized in nature and are thread safe. Traditional classes have synchronized collection, synchronized set, synchronized list, and synchronized map method through which we can get synchronized version of non-synchronized objects. Synchronized collections are much slower than their concurrent counterparts. Main reason of this slowness is locking. Synchronized collection locks whole object. It means when a thread is iterating over elements in a collection, all other collection method blocks, causing other threads having to wait. Other threads cannot perform other operations on the collection until the first thread releases the lock. This causes overhead and reduces performance. Concurrent collection achieves thread safety smartly. Example, concurrent hash map divides the whole map into several segments and lock only on segment, which allow multiple threads to access other collection without locking. Copy on write array list allows multiple reader threads to read without synchronization, and when a write happens, it copies the array list and swaps. So if we use concurrent collection classes in their favorable condition, example for reading and less update, they are much more scalable than synchronized collection. So copy on write array list is a concurrent equivalent of array list. Traditional collection throw concurrent modification exception if a thread is iterating a collection and if another thread tries to add a new element in that iterating object simultaneously. Concurrent collection does not throw this exception. Traditional collections are good choice for single-threaded application, whereas concurrent collections are good choice for multi-threaded application. Example, we'll be implementing example to show the difference between traditional and concurrent collection. Step 1 will be adding elements to an array list while iterating, and the program should throw concurrent modification exception. Step 2 will also be adding elements to a concurrent list while iterating with copy on write array list, which is a concurrent collection. Now let's implement this example in IntelliJ. So let's create a new class, and the class name is traditional versus concurrent example. So let's define public static void main, and let's implement our example for the first one where we'll be looking for concurrent modification exception in our array list. So let's create another method which is a static method, public static void and concurrent modification array list. So list of integer list is equal to new array list of integers. And for this looping, integer I is equal to 0, I is less than, let's say 100,000, and I plus plus this dot add I. So we are adding number from 0 to 100,000 in that list. Now creating a new thread, and this new thread will be adding a number to the list. So new thread and system out adding 5,000 to the list. So array lists allow duplicate, so we should not be having any problem with this. So list dot add and then 5,000. Let's start it directly. And afterwards, we have got an iterator object, iterator of integer it is equal to list dot iterator. And while it dot has next, it dot next. So first we are creating a list of 5,000, 10, 100,000 numbers, and then we create a thread, and this thread will try to add an item to the list while we are iterating the list. Maybe it might be better if I just put the system maybe thread.sleep time unit dot time unit dot millisecond dot sleep, and maybe for 10 milliseconds. Okay. And let's round it with try and catch. And here let's round this with another try and catch. And this is concurrent modification exception. And let's run this example. Let's copy this and call it within the public static void main. Let's run this example. So it is able to add 5,000 to the list. Let's put a timeout of 100 milliseconds. Let's run this. Still able to add it. So let's totally remove the timeout. Let's take this out and then run this program. So let's modify this example and use the cyclic barrier, because cyclic barrier both the threads will wait. So the issue what's happening is that the iterator is finishing before I can before I get a chance to insert that barrier. So let's add the cyclic barrier, because cyclic barrier will wait. So let's create a public static final cyclic barrier is equal to new and cyclic barrier with 2. And here you can just totally remove this timeout. And before, what we can do is that we can have cyclic barrier dot await and add catch clause. And inside the iterator, what I'm going to do is that I'm going to create a variable boolean flag is equal to false, and if not a flag, then cyclic barrier dot await and turn the flag to false. True. So that next time it won't execute. And then here add exception to method signature, and here add handle to method signature. And now let's run this program. So you can see that concurrent modification exception has been thrown. So before before it was adding 5,000 to the list before it comes to the iterator, and that's the reason why we were not getting the exception. Now cyclic barrier came to the rescue, and here we are waiting for, that's a touch point for both of them. Cyclic barrier await just before adding this number to the list, and inside the iterator I added up another touch point. So both the threads will wait and throw the concurrent modification exception.